Thank you everybody for coming here. My name is Henrik Bernquist. I'm the product manager for our range of products for intumescent coatings called Charmor. And during the presentation today, I will discuss the trend of using architectural steel and the need of fireproofing upon a fire. I will discuss different ways how to protect the steel in case of a fire, and then go more in depth on the intumescent technology, and then to finally wrap up with how to formulate a typical intumescent paint, and also the products that Pastop offer for this technology. Actually, I realized now looking through the presentation, I might have a couple of too many slides considering the time. So some of the slides might go a bit faster, but all the essential information will of course be mentioned. So as you all know, steel, of course, it can't burn on its own, but it loses its structural integrity relatively fast at degrees above 500 degrees. And in case of a fire, the temperature can easily or relatively quickly rise to around 1000 degrees, and consequently the steel as well, unless protected properly. And this occurs already at 500 degrees. The steel starts to lose its integrity, and also to prevent the building from collapsing, a building like this, in case of a fire, the steel structure holding up the building would get softened and the building could collapse. So in order to prolong the time for evacuation, you protect the steel. Also, for the architects, there's a more and more trend towards more visible steel beams, and then the need of protection is even more critical. In the past, you could hide it behind walls and behind gypsum boards, for example, but if you consider, for example, airports, usually the steel beams are visible and hence exposed to fire. So there are different types of passive fire protection, and intumescent is such a technology, a passive fire protection. An active fire protection would be like sprinklers in the roof. So this will only go off in case of a fire. And the fires are divided into three different categories depending on the material burning and the heat development and the temperature during the fire. The standard fire is this cellulosic fire. That's an ordinary fire in a home or a mall or an airport. It's when the wood and for example, paper, fabric is burning, carbon sourced material. The heat release is relatively slow, and the temperature goes up to around 950 degrees. Then the hydrocarbon fire, that's more on an oil platform, for example, where oil leakage or gas has been lit on fire. And then the most severe is the jet fires, who can reach above 1200 degrees. But that is more on a chemical plant, or when hydrocarbon fluid is really pressurized and it's more like an explosion. So for the intumescent or the past performance of the fire protection with an aesthetically appealing surface. Other products you could use is spray-applied fire-resistant materials such as concrete. And basically we just slab on concrete on the steel beam. So as you can imagine, that's not very pretty. Here with the intumescent coating, you can choose, you get a very smooth surface, and you can choose the color you want. So what is an intumescent coating? It's basically a 1K paint, physically drying. But you have these three critical components. You have the acid donor, the blowing agent, and the carbon donor. Pastop supplies the carbon donor called Charmor. And the intumescent effect, it occurs above 200 degrees, and on the next slide you will see the effect of the foam formation. And the paint applied relatively thick, I would say maybe 1000 microns, it swells to 40 to 80 times, so you get a really thick carbon foam. And this is applied both to steel structures, but could also be applied to wooden structures to prevent them from burning. For example, in the roof like this, it could contain intumescent paint. So here you can see, upon a fire, the paint, as any ordinary paint, then the binder melts, and there is a reaction between the acid donor, it decomposes, and then the phosphoric acid which is formed is reacted with the carbon donor to make this kind of a foam. Then you have a blowing agent which decomposes into nitrogen gas and then lifts the foam. So you get this very thick foam isolating the steel beam and therefore isolating it from the heat. And this foam, it has to be very strong and stable, because in a wildfire there's a lot of turbulence and wind going up, so the foam can't be blown away, because then suddenly the steel is exposed instantly and you lose the whole concept. So it's very important when you formulate the foam. So for the cellulosic fires, the ordinary fires, there are both solvent-borne and water-borne paints available. The solvent-borne tend to be used more to exterior applications. They can use throughout the whole year, because contrary to water-borne paints, they are not really affected by the humidity and frost and so on, not to the same extent at least. For indoor applications, the water-borne are more popular, and also in already occupied buildings, the water-borne would be more preferred due to the lower odor. For a hydrocarbon fire, if you remember, these were the more severe, up to 1100 degrees. There you need coatings with much higher durability and mechanical properties. So these are 100% epoxy-based, but you have the same effect of the intumescent technology. Being epoxy-based, then you need a top coat to give them the UV resistance. But since these are very durable, they are often used on places where it's very difficult to do maintenance, and you want a very long-term durability. So like onshore and offshore platforms, refineries, petrochemical complexes, processing plants. And the Charmor is used both in these kind of systems and these kind of systems. So this is just a simple formulation to show the concept of formulating a intumescent paint. I wouldn't go to my plant tomorrow and produce it. It's more like a conceptual formulation, though. But as I said, it's made like any ordinary 1K component or paint. You have the resin. Where is it? And you have the active components, the ammonium polyphosphate, the Charmor, and the melamine. Roughly, you say use this 3 to 1 to 1. Then in the second part, you let it down so you grind all the active components first, then you let it down. And here in the waterborne, you have a polyvinyl acetate resin. You can see here, and I will show you on the next slide, we have two different grades, and I will come back to that. So here, this contains the two different grades, so you will see the difference among the two on the next slide. Here we have done a fire test. So this is made in an oven, and here you can see the temperature of the oven to represent the fire development. It goes very quickly here in the beginning. The temperature rises very fast. An unprotected steel beam, the temperature of the steel beam rises almost linear. I say this shouldn't be there, of course. But you usually measure something called the T500, which is the time it takes to reach 500 degrees. And as you can see, for an unprotected steel beam, this occurs in less than 15 minutes. Whereas with the intumescent paint, you get a this is before the intumescent effect has occurred, so it's very close to the unprotected steel. But here you can see the effect of the insulating foam. And the finer grade, the PM15, it prolongs the time some slightly more. And basically this time here is the additional time you get to evacuate people from a burning building. It can be anything from 30 minutes to 120 minutes. So the products that Palstop offer, it's the three different types of carbon sources. And remember, you need all three components. It's not just enough with the Charmor, nor the APP, or the blowing agent. What differs among these grades is the melting point. And the melting point, it also has an effect on the offset temperature. When does the intumescent effect start? And also another big difference is the water solubility. For an indoor or water resistance, for an indoor intumescent coating, these grades are sufficient. Whereas if you need a very high water resistance, for example, on an outdoor application or a very humid climate, you would need a very low water solubility. This is to prevent that the water or humidity is extracting the active components from the paint. And then, as I said, we offer two types of particle sizes: the 40 grades and the 15 grade, and these are available for all of the products. And I would say the difference is a very fine grade, or a much finer grade, then that will be even more evenly distributed throughout the paint. So when there's a fire, it's an even more, when it's activated, it's even more efficient compared to the 40 grade, so you will get a higher foam. The drawback is that with the very expanded foam, it can be more lower density foam, less strong foam. So there is the risk of having that the foam is blown away in a fire is higher. So with the 40 grade, you get a more compact, more stronger foam, a more stable foam. However, the expansion factor 20 is very well enough. This is mainly to illustrate the differences between the two grades. So Palstop, we have a dedicated line for these products. It's we produce them from the very first raw material up to the final milling, and the milling is very important for these type of products. There shouldn't be any coarse particles, because that will affect the char formation. And the Charmor, it's a non-toxic, non-hygroscopic product, and with a very well-defined and good particle size distribution. And this is our latest innovation. We've taken the opportunity here at the European Coating Show to present it. So what we have done is we have taken the main product, the Charmor PM40, and we have made it into an exact analog with a lower carbon footprint and a better sustainability profile. This has been made possible thanks to the usage of renewable energy, and also a part derived from renewable raw materials. So here we offer a simple way to produce the exact same paint formulation with the exact same specification, but with a lower carbon footprint. And it's a good way also as a marketing tool to show, to further strengthen your sustainability profile. So we have a long history in polyols and for the intumescent business, over 30 years. As I said before, we have our own production facility with a dedicated line, so there is no risk for cross-contamination. We have a global sales force and a global distribution network, so we can supply anywhere over the world. We have a very good and appreciated technical knowledge and technical support we can offer to people wanting to look into this technology. However, we can't certify as you are required to do with these kind of products. That needs to be done by the authorities. So to conclude, the increased demand of architectural steel, that puts much higher demand on the fire protection, and people want it to look pretty as well. And this technology, with both the high performance and the aesthetically appealing looks, it's I would say a winning combination. But remember, you need all the three critical components: the carbon source, the Charmor, the ammonium polyphosphate, and the blowing agent. And we offer then the three different grades with different melting points, and also the different water solubilities, depending on the environment you want to use this paint. That's it for me. Any questions? Then it means it was crystal clear.